Welcome back. So now we're going to talk about surds. Now a surd is simply a word to describe a square root. So any kind of expression in maths with a square root is known as a surd. Now there are quite a few rules that we're going to use to manipulate surds. So let's look at the first one here. So we've got root of a times root of b is equal to root of ab. So practically what does this mean? Well, imagine we had root of 3 times root of 5, then that would simply be root of 15. Now a special case of this would be if we said, for example, root of 3 times root of 3, well, that would be, using the same rule, root of 9, which we know as 3. So here, if you have the two numbers being the same, you don't need to go through, you don't even need to use this rule. You could simply say that the answer would be 3. So root of 5 times root of 5, in the same way, without even using this rule, you could just simply say that that is 5. So that's probably an easy way to do it than to use this rule up here. Another rule that you should be aware of here is root of a divided by root of b is actually equal to the root of a over b. So an example of that would be something like, let's say, root of 5 over the root of 3. That's the same as 5 over 3 all square rooted. Another thing that's important to know is how can we add surds. So a way to think about it is to treat the surd like you would an x value. So in other words, this answer would be 2 root 3. So if I draw, if I write underneath x plus x, so if you treat the root 3 like an x plus x would be 2x. So in the same way, root 3 plus root 3 is equal to 2 root 3. Now one thing to mention is this only works, you can only add surds when the numbers are the same. So if you wanted to try and add root 3 plus root 4, well, you can't combine those as a root. There's nothing we can do with that, apart from to say that it's the same. Okay, so here is now quite a common question. They want you to simplify root 18. Now what we mean by simplify when it's a surd is we want to try and take a number, really the largest number we can outside of that root. So the way you do this is you think of two numbers multiplied together to give 18, but specifically where one of those two numbers is a square number. So square numbers would be things like this: 1, 4, 9, 16, 25, etc. So these are all square numbers. So two numbers multiplied together to give 18, where one of them is a square number, that would be 9 times 2. And then what you can actually do is you can take the square number outside the root. But when you do that, you just have to remember to square root that square number. So it will now become a 3 outside, and then we've got the 2 inside. So this is quite a common question. So let's try and bring everything together now in a trickier question. So here we want to simplify this expression. So the way we could approach this is to try and look at each individual surd and bring the largest number we can outside the square root. So if we look at the 6 root 3, well, there's nothing we can bring out of that. That's as simple as it's going to get. Now this root 48 here, we can do something with that. So let's look at root 48 on its own for a minute. So root 48, we know that we're thinking of two numbers multiplied together to give 48, where one of them's a square number. So that's going to be 16 times 3. And then we can take the 16 outside the root, but we need to remember to square root the 16, so that's going to be 4 root 3. And then let's do the same with the root 75. So same kind of idea, two numbers multiplied together to give 75, where one of them's a square. Well, 25 times 3. Now we can take the 25 outside, that's going to be 5 root 3. So now let's bring everything together. So this here will now become 6 root 3, no change there, times minus 2, and then instead of the root 48 we're going to put times 4 root 3, and then plus 3, and then instead of the root 75, we're going to do times 5 root 3. And then we're going to simplify this a bit more. So that's going to become 6 root 3 again, minus 8 root 3, plus 15 root 3. And now what we can do is treat these root 3's like x's. So imagine we had 6x minus 8x plus 15x. So that would be 13x, or in this case 13 root 3. So one last question here. We would like to expand and simplify this expression. So this is very similar to expanding double brackets, which we covered in a previous lesson. So the method would be, again, just to recap, we're going to times the 3 by the 1, we're going to times the 3 by the minus 3, minus 2 root 3 by the 1, and minus 2 root 3 times the root 3. So let's do that. So 3 times 1 is going to be 3, plus 3 times root 3, so you just write that as that, 3 root 3, minus 2 root 3, and then be careful with this last one, it's actually going to be minus 2 times 3. Now let's just discuss where this comes from if you're not quite sure. So really what we're doing is minus 2 root 3 times root 3, and then just looking at these, we said earlier that this would just be 3, and then we're also still timesing by a minus 2, so minus 2 times 3. So then if we were to simplify all of this, it's going to be 3 plus 3 root 3 minus 2 root 3. Let's just simplify this bit, so that's a minus 6, and then we can collect these terms, so that would be a minus 3, and then treating these like x terms, we're going to have root 3.